result of negative 4, 0. The answer that we're getting here with the answer that we got when we did this, when we drew it out a few moments ago, notice that our resultant, if you start right here and you go over 1, 2, 3, 4, that is negative 4, 0. That is exactly what that resultant is. So we've seen how we can do these graphically or algebraically and come up with the exact same answer. So it's really just your preference as to which of those you like better. You're going to get the same thing either way. All right, so a couple of things about unit vectors. We've already said that a unit vector is a vector that is 1 unit long. But sometimes you may want to find a unit vector that is in a particular direction. For instance, let's say that we're looking at the vector negative 3, 4. Negative 3, 4 is not 1 unit long. If we find the magnitude of that vector, as we've done several times already today, its magnitude would be 5. So that's not a unit vector. I can find a unit vector, however, that is going in the exact same direction as that vector. And the way that I would do that is I would take the component form of the vector and I would divide it by its magnitude. Because if this is 5 units long and I want it to be 1 unit long, I just divide it by 5, right? So let's do that. Let's take our component form of our vector, negative 3, 4, and let's divide it by its magnitude. As we already said, that magnitude is going to be 5. So we'll take our component form, negative 3, 4, and we'll divide it by 5. So we'll end up with negative 3/5 and positive 4/5. So if you graphed the vector negative 3, 4, and you graphed the vector negative 3/5, 4/5, they would go in the exact same direction, but this would be 1 unit long where this was 5 units long. So this is a unit vector that is going in the same direction as the vector that we started with. Something else that we do with our unit vectors is we work with standard unit vectors. Now, we've already talked about what a standard vector is, or a vector that's in standard position, and we just said that that means that its initial point is at the origin at 0, 0. We've also said that a unit vector is 1 unit in length. So a standard unit vector is going to be one that starts at the origin and is 1 unit in length. So 1, 0 would fit that bill. 0, 1 would fit that bill. Those are 2 standard unit vectors. So we're going to call 1, 0 I, and we're going to call 0, 1 j. With each of the vectors that we have looked at today, like let's say we're talking about negative 3, 8, that's a vector that's in component form. We could rewrite the component form of any vector in standard unit vector form just by taking the first value and adding I after it, taking the second value and adding j after it. So negative 3i plus 8j. And they give you a formula for that up here as well that you can see does that exact same thing. Now, if you're looking at these two things and you're going, how in the world can those be equal to each other? Well, let's just see. I have negative 3i plus 8j. So I'll come down here. Negative 3 times I, we said I was 1, 0. Plus 8 times j, we said j was 0, 1. So that would give me negative 3 times 1 is negative 3. And negative 3 times 0 is 0. 8 times 0 is 0. And 8 times 1 is 8. So now I have 2 component forms to add. So negative 3 and 0 is negative 3. 0 and 8 is 8. So exactly, we started with negative 3i plus 8j, and we ended up with negative 3, 8. So on the homework tonight, for some of the problems, instead of giving you the vector in in component form, they're going to give it to you in standard unit vector form. You are more than welcome to take the standard unit vector form and just pull out those leading coefficients, just the coefficient of I and the coefficient of j. Pull those out, and that will be your component form of your vector. Or you can work with it in standard unit vector form as well.